Howdy, partner.
Hey, Ellen.
Hey.
What's up, girl?
Hey.
Oh, and Sydney. I didn't know this was going to her.
Hi, Sydney.
Okay.
Okay.
We have talked about transformations. We are going to focus on translations today. Okay. Mapping notation. You're going to take some point, we're going to translate some point, x, y, into another point where we're going to have x plus 2, I didn't mean to parentheses, comma, y minus 1. Okay? All that means is we're going to take an x and a y, and we're going to move the x 2 units to the right. So we're going to add 2 to the x. The y, we're going to move 1 unit down, so we're going to subtract 1 from the y. Okay? So let's get a triangle. I'm not even going to draw this one. I'm just going to give you coordinates. Triangle A, B, C. And A will have coordinates 7, 3. B will have coordinates 10, negative 1. C will have coordinates negative 2, 5. Okay? We are not even going to draw it. I'm sorry. Well, I promise I will give you plenty to draw today.
No, that's okay.
Oh, I have a question.
Yes, ma'am.
What is our final going to be? Is it going to be lessons 1 through
80.
How many
But-
questions?
It's about 50.
Oh, that's good news. Okay.
Just like your midterm, we will have a test. Lessons, like midterm, we had a test, lessons 1 through 40. The next week we had a midterm, lessons 1 through 40. We'll take a test, lessons 1 through 80, and then we'll have a final, lessons 1 through 80. I mean, it's different material, obviously, but it's not too crazy.
Okay.
About half of it is multiple choice, the other half is short answer, fill in the blank kind of stuff. Work your problems like a normal test. All right, so we're going to take this x and y, and we are going to map it to, I didn't mean to say that. We need to map it to A prime, which is 7 plus 2. I took the x value and I added 2. We're going to take the y value and subtract 1. So that should be A prime is 9, 2. Does everybody see where I got all these numbers? 7 I pulled from the x, plus 2 is going to be right here. Every time. We'll circle that. So here we go. So where do we go with B? We're mapping B prime to 10 plus 2, negative 1 minus 1. So B prime will be 12, negative 2. C prime will be negative 2 plus 2, 5 minus 1. So C prime is what? 0, 4. Not hard. Mapping notation, all of these are going to be the same. We're going to add the same amount to your x's. We're going to add the same amount to your y's. Sometimes you're going to subtract if it's moving down or left. Okay? Mapping notation is just a little different. So when we go, I already have grid there. What if I just draw something for you? Okay? Does it have to be a triangle?
No.
No, I can draw any shape I want. Generally not a circle, but a polygon of some sort. Yeah, let's just make it a 4-sided shape. How about that? A quadrilateral of no, oh, that's not a really straight line. So we're going to have a A, B, C, D. In your book, they talk about isometric transformations. What does isometric mean?
All different.
Kind of
Isosceles triangle.
What makes an isosceles triangle?
Different pictures, they're all different.
What?
That's scary,
What's isosceles?
Two congruent sides.
At least two congruent
At
sides
least.
or angles. Isometric means they're all the same. It will be the exact same shape, exact same size. It will have the same perimeter. It will have the same area. I need you to draw the shape. A, B, C, D. Yes.
Why can't you say congruent?
It means the same thing. Yeah. When they're talking about shapes, when you're making transformations, an isometric transformation means it'll have the same perimeter. It's going to have the same everything. They will be congruent. Yeah. Yeah. It says translation is an isometric is an isometry. Means the same thing. Meaning the pre-image and its translated image are the same shape and size. Can you use? Oh wait, I didn't tell you where to move this, did I? I'm sorry.
No.
We're going to transform the XY. We're going to translate the XY. X plus 5. What am I going to do? A comp parentheses there. The first thing you're going to have to do is find the coordinates. So I want you to translate it and find the coordinates. A lot of times they will say, put the image and the pre-image on the same coordinate plane. So this is your pre-image. After you move it, that's your image.
So I thought someone broke my highlighter. Oh my god. Always blaming things on everybody else. So we have to find the coordinates of
So you
those
probably
first.
need to find the coordinates of A, B, C, D first.
Which one's the x-axis?
The horizontal.
This is always the x-axis. This is always the y-axis. It's why you go right and
How
left
did they
first.
decide that?
You know, I never really thought to ask that question.
How did they just decide
Because-
any of this?
I mean, I think
Why is it even?
this, I mean, you're going to walk horizontally, I don't know, because this is 0 degrees. X comes before Y, so that goes first. And then Y is going to go there.
But also, who decided they put the X on that side? Why don't you put it on the left
I
side?
didn't make it big enough.
Really, they doesn't matter. You can put it right there. This is the x-axis. And it's the arrow going both directions.
Oh, it barely fit. Wait, so it's A? Negative 5, 5.
Mm-hmm. What? I think it's 4. Negative 5, 4. I think B is negative 5, 0. C
I did
is
it wrong. I did it wrong.
1, negative 1. B is negative 1, 3. I believe are your coordinates.
Well, I gotta redo this. Darn.
Actually, Jesus history. I'm done. I did it.
Yay!
Although it's kind of interfering with my top stuff, but it's okay.
It will probably get into mine.
Oh.
Maybe not.
Man.
So, Landry, can you tell me the coordinates of A prime?
10, 6.
How do you do so fast?
Whoa.
10, 6.
That's how.
Whoa.
If we write it like this, we are taking negative 5, 4.
Negative. Oh, no.
Did you go to positive 5? Or did you graph it on positive 5?
Watch me get this right.
Yes, sir.
So is this supposed to take long?
No.
What?
Mm.
Because I'm struggling to do this one, right?
I got it.
Just let me regraph it all.
Okay, Zach.
All my
A prime.
A prime.
0, 7,
6.
6,
6.
0, 6.
What? What?
0, 6.
Wait.
Like you don't have to write out the long steps of plus.
Oh, that was my. I did that wrong. Wait.
B prime. I probably should scoot this whole thing over.
You got A prime, right? I got 0, 6.
A prime is 0, 6.
Yes.
I agree. I'm not generally gonna
I got
write.
that too.
B went from negative 1, 3 to what? B prime
4,
is 4,
4.
5. Yeah, I'm gonna run out of space.
Wait, I'm like perfectly with you. So
C, that was 1, negative 1.
Oh,
What does
I'm
it map
so
to?
stupid.
6, 1.
It's fine. It's okay.
And D prime. D, well, stop. D, which was negative 5, 0. It maps to D prime, which is what?
0, 2.
0, 2. So this is your mapping notation that's listed. I also asked you to graph it, which we should be at
Yes.
4, 5, 6. Here's A prime. B prime is
I made a simple mistake. It's fine.
4, 5. B prime, I may or may not get in the midst of all my stuff. C prime, 3, 4, 5, 6, 1.
What?
C prime.
This doesn't look the same.
Why?
I
It does. Wait, hold on. C. 6.
Oh, whoa. Stop. Why did I go over
Oh my
there?
gosh, I was doing the y-axis, or the y first.
0, 2. So look at another thing you can look at to check yourself. From A to B, you went down 1 over 4. Do we go down 1 over 4? Yes. From B to C, do we go down 1, 2, 3, 4 over 2? 1, 2, 3, 4 over 2. Yes. From A to B, did we just go straight down 1, 2, 3, 4 units? Yes, we did. Yeah.
Oh my goodness, yay.
Wait, what?
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 Another way to check yourself. Okay. If they're going to be isometric, meaning the length from A to B has to be the same length from A prime to B prime.
Or you can just move
I like
each
this.
point the 5 ways. Like if it's going positive, then it has to go right. And if it's going positive on
It's
the
gonna
y,
go
then it goes up too.
Yes, that is the way you've always thought about it. It's still the same way to think about it. We are just using a different way to write it. Okay? It still means the same thing. You can still move it x is over to the right 5, y is up 2. That's all that says. Okay? At some point in time, you're going to be asked to write mapping notation. Okay? They're not even going to ask you for an image or a pre-image. They're only going to ask you for mapping notation. That's why I'm kind of making a big deal about it. Okay? Do we need to do another one?
Sure.
Sure.
Do I have to draw it?
Can you do?
Do I have to draw it?
Like, can you just do the coordinates?
You like
Oh,
just doing
drawing is
coordinates?
fun.
Yes.
I like drawing it because it's like perfect.
Because I don't
Yeah.
want to
No,
draw
I
it.
like doing the coordinates.
Look at that.
Look at this
Okay.
girl. Time.
They can draw it.
Look at this.
Um,
Personally.
Clean.
Alright.
Nothing is perfect. No, let's not be vectors. Let's keep going.
No matter what, we're doing translations with mapping and vectors. So there's another way.
No.
Yes. There's another way that will
That's good.
actually be even better. You'll get some satisfaction out of it.
I hate vectors.
No.
Very good.
You can't hate vectors.
I do.
What is a vector? What is a vector that makes you hate it so much?
I
It's
don't.
a what?
Arrow.
It's an arrow. It's represented by an arrow.
It's a ray.
It's a ray.
I say everything about it.
No.
I just don't like them. They're confusing.
Direction.
It really couldn't be confusing.
it's like everywhere. They don't have coordinates or anything.
That's right. You can put the coordinates anywhere you want. So our initial point always needs to go where?
0, 0.
The origin,
If you
0,
want to.
0. Your terminal point goes,
Wherever you want.
well, whatever the components are. So if I just wanted to draw this vector, could you just draw this vector?
Sure.
Vector.
So you go where?
Wherever you want.
Start at 0, 0.
Over here.
And what are we doing?
4,
Four.
negative 2.
So to the right 4 and up 2. Is this?
No,
No,
negative
down.
2.
Oh, it was negative 2. Sorry. That's a vector. 4, negative
So
2.
could you copy that
That's like
and
perfect.
then just put it up there? And it'd be the same.
I can copy that and put it anywhere I want to.
And that's still
Oh,
4,
that
negative 2?
Yeah.
I don't like that.
I don't like that it won't hit on the corner. But that's not my issue. So now, how are we going to use these vectors for translation?
You translate them to the center.
Okay, what if I give you a shape? Let's do. I like quadrilaterals.
Is today Tuesday classes?
It is Tuesday classes.
What do you need to do? Physics.
All right. We're gonna pretend.
Oh, nuts.
Oh,
I knew I forgot something.
Okay, W, X, Y, Z. I give you a polygon. I'm pretty sure it's a quadrilateral. I think it might be a parallelogram. We won't go into proving that yet. Okay? So if I wanted to translate this quadrilateral by the vector A that has these components. I've already drawn it once. What in the world are we going to do?
Wait, what?
We're going to take this polygon, W, X, Y, Z, and we're going to translate it by the vector A.
Oh, I have absolutely no idea.
Guess what? What do you think we're going to do, Zach?
Well, we put the vector on a point, and then you're going to move the point to where the arrow is.
That's what we're going to do.
And then you're going to
Yes,
move to the next
Matt.
Oh, that's cool.
So actually, you know what I'm going to do? I'm going to duplicate it. I'm going to duplicate it again. And I'm going to duplicate it again. So I have 4. So all 4 coordinates are going to be translated.
How do you know which? Never mind.
Which one is the?
So it's like those
Kind
kites.
of cute.
Why?
You gotta put
Why?
it lower.
It moves it.
Put it lower.
It can't be in the center of a dot.
It should be.
Well, they're all like.
Imagination.
It looks like a table.
Should I erase them and do them all?
No,
No.
it's alright.
Okay, we can.
Erase them.
We can just make our dots bigger.
Nicole's just insanely OCD.
We can just make our dots
That's
bigger.
okay.
Okay, but we are going to put, because a vector is special, and we can put the initial point really anywhere we want. If we are making a
I
translation,
thought that the initial point had to be on the origin.
it doesn't. It just makes it really easy. They are really everywhere. We just put them at 0, 0 to make them easy to count and find components of.
Dang, it's already at 47%.
Yeah.
Dropped. Oh my gosh, Mac.
Because it,
Computers have the worst battery life ever.
Mine's
mine does not. You know what it does?
Mine's so
This board, it pulls from that.
Was it at
this-
100?
It was at 60, 61 when I unplugged it to start recording. So the board does not have any power to it. It gets power from my computer.
Ooh, that's
Whoa.
space. Whoa. Wow.
So yeah.
Did you hear that, Elliot? Elliot.
Elliot.
You just disrespected
All right. So we take each vector's terminal point is at the end of the
Okay.
vector. Okay? Then when we connect those points, like W was translated 4 units right, 2 units down. That is W prime. X was translated 4 units right, 2 units down. That's X prime. It's another way to say 4 units right, 2 units down. Y, 4 units to the right, 2 units down is Y prime. Z, 4 units to the right, 2 units down, we have Z prime. When we connect those dots,
You made a kite.
Isn't it nice when you can draw it? Not really. I think it looks like a box.
it is a 3-dimensional type shape. Okay? Yes. But you can see your image, you can see your pre-image, and you can see all your vectors. Okay? I don't know what's on my next page. Math, it does. Okay, we're gonna go back. We're gonna do one more that you have to do. Well, yes. Alright, so you were gonna translate. Apparently I did something else in the midst of all this.
Wait, can we do this?
Star.
Calculator?
I don't think so. Because you would need equations of lines.
Do a star.
Do a star. We're gonna have Q. R. Oh, that was not supposed to be a prime.
I don't think she says on my dog.
S. I cannot draw a star,
That'd be like.
just so
You
you
can't?
know.
David Star.
Of course. Of course.
Yeah, okay, this is just supposed to be a random thing.
Try it out.
Q R S T, and I was gonna bring it back.
Yeah.
Here, Q R S T U.
Now draw V at 0, 7.
0 down here.
Oh wait, no, 7, 0.
Here.
Negative 7, 0.
I don't know where
Yeah,
we're
right
going.
Okay, you can connect it now.
Should I go here?
Oh sure.
Yeah, that's what people say.
Okay.
Arrow.
Q R S T U V W. All right, so you're gonna translate this.
Yeah, it is an arrow.
Kind. Okay, I kind of see the arrow.
It's a chunky arrow. Arrow.
We're gonna translate it by the vector. 7, negative 3.
Do we have to do it?
Yes.
Whoa.
You should not have gone this far. I was like
My bad.
Yeah,
non-quadrilateral.
why would you do this?
2, 3, 4, 5, 6. Negative 6. I tell you what, I will at least give you the coordinates.
Oh my gosh, wait, we have to draw our own vector?
Oh.
I was just thinking we could duplicate it, but that doesn't work.
That doesn't quite work for you.
Oh my. Can I just do a triangle?
This is not.
I just gave you all the coordinates. You can do it.
Watch.
First you dye your hair.
Alright. It'll be fun, don't worry.
That's what they all say. That'll be fun. It has been said.
Wait, why is it? I'm stupid.
But what are we supposed to do once we got it?
You're supposed to draw, you're supposed to graph it, then you were supposed to translate it, draw the vectors, 7, negative 3. So I personally would start at the bottom. I'm going over 7. 2, 3, 4, 5, 6, 7, negative 3. That's U prime.
Cursed.
I wish we could duplicate like you.
I'm sorry. I'm not going to duplicate. I'm going to do all of them. 2, 3, 4, 5, 6, 7, negative 3.
Why can't we do this?
It's a good question.
1, 2, 3, 4, 5, 6, 7. 1, 2, 3. S.
Wait, how do you do your vector?
I go from the coordinate here. I'm going to count over 7. 1, 2, 3, 4, 5, 6, 7. And we'll go down. 1, 2, 3. So that's vector U. Or W prime. Okay, but this time I won't even ask you for more the other coordinates. We only have 2 more to go. Goodness. 3, 4, 5, 6, 7. 2, 3. R prime.
Oh my gosh, we can't connect the dots though.
3. Oh, yuck. Q prime is on the same line.
Oh, yeah,
So once you have all your vectors drawn, you're connecting Q, R. Oh, where did my S go?
S is down.
S is straight down. All right. Q to R to S to T to U to V to W
My brain's all jumping.
back
Oh,
to Q.
I'm not doing that.
I can't see.
It's like it's on drugs.
No.
Everyone just look up from your paper and see what is on the
Oh! I'm going to try to draw Q, R, S, T. I should have drawn it in different colors. Does the green shaded? Oh, why am I in red? I should be in green. Q to R to S to T to W to V to W back to Q. Does that shape look exactly like your original shape?
I can't do that.
Why? You
There's-
can do that.
Wait, there's much.
You also, first thing is, you need labels. When you are graphing this, if you are not writing labels, at least write Q, R, S, T, U, V.
You have to believe in yourself.
Yes.
Yes, motivational speaker.
You can do some shading. Zach has done some shading.
Oh, I see.
Now, should this be a prism? Whatever shape it is, it should be a prism. Yes, Lily, we could. We could find the volume.
We won't.
I will not force you to, especially with this shape.
I would watch out.
But if you had the area of your original shape, you could simply multiply it times the magnitude of your vector.
Wait, what's the magnitude of
What is the magnitude of a vector?
It's length.
The length or the distance. Distance formula.
Oops, I drew
No,
one.
it's right there.
Dang it, I messed up.
There she goes.
Okay, I did that too, and I undid. You can't quite undo yours. Alright. There's an application talking about computer animation on page 474. A character in a new animated movie will move from point 4, -5
Are you serious?
to the point 16, 3 to another point. Sorry, I know, I'm sorry. I'm moving on because we don't have a lot of time left.
I was almost on. I just needed one more point. And you just left me behind. That's not what Jesus did. He went after every loss.
The lost shoot.
You could have finished
Nicole,
by
you
find something.
haven't even done the same.
Wow. Okay.
Alright. On on 474. If you have drawn the shape, we've moved to page 474.
Well, there's a UFO.
Yes. And that UFO is moving.
It looks like a cloud. They really just do it.
It's an
Yes,
animation.
'cause you know what you have.
Yes, they did. Look, they got lights and everything.
It looks like it's raining.
No, yeah,
It looks like a shower.
Use your imagination, Nicole.
Yeah, well, she has
It's a
Use
cartoon
your
imagine-
imagination.
animation. Alright, so are we good? We can draw this. We have just used vectors.
Sure.
Alright, so we are going from one point, first point to a second point, to a third point. What vector did they move to get from one first point to the second point?
Twelve.
And 8.
8. So they moved from 4, they moved 12 units to get to 16. The y was at negative 5, they moved 8 units to the right to get 3. Up. Okay? To get from the second point to the third point,
-3, -5.
very good. That one's pretty simple.
Done, Zach.
Alright. We do have some homework.
Oh, we have a test.
I have scheduled a test for Friday. This is week number 5.
What?
It is time, because Lily has already brought up the fact that finals are approaching rather quickly.
Why?
So I am giving you a review.
I was in the fire meeting.
Miss Ivan.
Yes. So,
Wait, no, not 8. I didn't work this week. Wait.
Andrew, what's so tough?
Yeah,
Do
Miss
you-
Ivan.
Yeah.
Can we